Alright, good afternoon. I have not finished grading yet. Tweets over the break. So hopefully tomorrow, by end of the day, I can finish it.
Keep the spirit of giving in your heart as your grade.
I mean, enjoy your break. I'm gonna post the grade after that.
Oh, thank you.
So
Wait, after the break?
He doesn't want to ruin our grade.
yeah, I just don't want to ruin your. If you want, you can stop by the first
stressing out over break because of what we might have done?
If you want to cry in front of your family,
I'd rather cry here and find out
Is it
tomorrow.
bad, Dr. Doggett?
No, I mean, I finished the first
My
problem.
family's at home.
He said the Brandon thing is not. But if I'm not so correct, he's healing
So grand.
I remember I asked.
I would assume most of them.
I didn't mention that we should be on the budget. So let me know that we discussed and we go for a response. I think he's grading based on the other solution that I provided. Alright, today we are gonna work on synthesis of four-bar mechanism to generate motion. So we have a motion generation problem. What was the motion generation problem? So if this is the x and y axis in two-dimensional, we would like to move this rigid body, from this position to this position and this position. This is a rigid body like this one. And we would like to move it through these three precision points. It's a motion generation because it's tracking the motion of a rigid body. So the goal is finding a four-bar mechanism to move it through these three precision points. So this is the goal of motion generation. So if I look at, for example, this line, line AB, and track this line here, and track it at this third precision point. And the rotation of this line from this position to this position, it's gonna be I have this line, I move it here, then I move it there. So this line has been rotated by the angle of 30 degrees, for example. And then this line has been rotated by the angle of 90 degrees. Since it's rotating counterclockwise, it's going to be positive. So this line from first precision point to the second precision point has been rotated by 30 degrees. And from first precision point to the third precision point has been rotated by 90 degrees. So now if I ask you, consider the other line. Consider this line. and follow that line in. Follow this line in 3 precision points. What would be the rotation of this line from this position to this position? And from this position to third position? Same as, exactly, same as if you just track one line of the rigid body over the 3 precision point, the other lines they are gonna rotate at the same angles. So I can say that the entire rigid body from first precision point to the second precision point has been rotated by 30 degrees, and from the first precision point to the third precision point has been rotated by 90 degrees. So saying that if you know the coordinates, if you track the coordinates of one point in this rigid body, suppose point P, it has x1 and y1 as the coordinates. Track this point on all 3 precision points. Also track the rotation of the rigid body from first precision point to the second, and from the second to the third. So just look at this line, for example. The angle of this line with the ground is 0. This is this line. I'm following this line in all 3 precision points. From first precision point to the second precision point, if I call it gamma 1, 2, it's going to be gamma 2 minus gamma 1. It's 30 degrees. And from first precision point to the third precision point, this angle, it's gamma 1, 3. It's gamma 3 minus gamma 1. In this case, is 90 degrees. So how can I represent the motion generation? Just presenting position of 1 point in 3, desired position plus gamma 1, 2 and gamma 1, 3. What would be the rotation of rigid body from the first precision point to the second precision point and from first to the third? If I provide this information, this is going to represent the desired motion that we are looking for. The application for that, we have these conveyors here, conveyor 1, conveyor 2. So you would like to design a 4-bar mechanism such that it's going to take these parts from this conveyor at this orientation, and it's going to move it to this desired position at this orientation, and then it's going to move it to this third precision point at that orientation. So it's kind of moving this box through these 3 precision points. When the 4-bar mechanism is going to pick this box, the box is going to be part of this terminal mix, which is a coupler. So then whatever is the motion of this box, it's going to be the motion of this coupler link. So we would like to design a 4-bar mechanism. 1 is ground, 2 is a coupler, 4 is this guy, such that one point of that, which is point B, moving along these 3 precision locations. Also, this wing is rotating by the angle of gamma 1, 2 from first to second, and gamma 1, 3 from first to the third. So the idea is, the goal is finding the location of the joints O2 and O4 and size the length of all 4 links. This is what we are going to do. Okay? that clear? Any questions so far? Alright, let me get rid of this. Just leave it with this one. If this is y, this is x. If this is the location of O2, this is point P, and this is O4. This line is parallel to the ground. This angle, we call it gamma, representing the angle of this part with the ground. And gamma 1, 2 is the orientation of the coupler link or this Turner link from first precision point to the second precision point. And from the first precision point to the third precision point, it must be gamma 1, 3. Also, point P of this coupler or this Turner link should move along these three coordinates: x1, y1, x2, y2, x3, y3. So what we need to find the location of O2, the location of O4, this length, this length, this length, this length, and this length. So what we are going to do, we are going to define a couple of vectors. This is the first thing. Vector V1 connecting the origin to the O2. Vector V2 connecting O2 to point A. Vector V3 connecting point A to P. To do the job, we divide the entire of the mechanism to two parts. Diode 1, diode 2. So in first step, we are working on V1, V2, V3, and by doing the analysis, we will find the location of O2 and this vector, the length of this V2, and the angle that we should start the mechanism at that angle, and V3 also. So after we are done with the diode 1, we define V4, the vector connecting the origin to O4, V5, the vector connecting O4 to this point, if I call it V, and V6. By working on diode 2, we are finding the location of O4, the location of V, and then this length. And we are done with the motion analysis. So if I draw the first diode here, so this is vector V1, I draw it here. This is vector V2 with the angle of theta 1 at the starting point, and this is vector V3 when point P is at the starting or first precision point with the angle of gamma 1. Then point P should move to location of x2, y2, for example, somewhere here. this link or this line, which is a part of this terminal link, should rotate by the angle of gamma 1, 2. So what I'm going to do, I'm going to draw a line parallel to this. Parallel to this. Then I rotate it by the angle of gamma 1, 2, which is going to be this one. So if this line is parallel to this two, this angle should be gamma 1, 2, because you are going to rotate this rigid body by angle of gamma 1, 2, and this point should represent x2, y2. This is going to be this. Location of O2 is not going to change, but this link is going to rotate to this position, and this angle is going to be theta 1, 2. It's rotating from first precision point to the second precision point. Do the same thing for the third precision point. It's going to rotate, for example, by the angle of theta 1, 3. And if I draw a line parallel to this here, this line should represent gamma 1, 3, and the coordinates of point P can be here, x3, y3. Then you can have this one like this. So when vector v2 is moving from first precision point to the second precision point, the vector v3 is going to moving from this location to this location by the angle of gamma 1, 2. And when it's rotating by theta 1, 3, this guy is going to rotate by angle of gamma 1, 3 from the first precision point orientation. So this is what you can see on first diagram. On this slide, we have this. This is vector v1 with the length of a and the angle of alpha. This is vector v2 with the length of b and the angle of theta 1. And we call this length as c with the angle of gamma 1. Then the mechanism is rotating from first precision point to the second precision point. This line should rotate by the angle of gamma 1, 2. So if you draw a line parallel to this, the angle between these two should be gamma 1, 2. And point P should move from this coordinates to this coordinates. And if you connect this angle is going to be theta 1, 2. And third precision point, you draw a line parallel to this. This orientation should be gamma 1, 3. Point P3 is going to be a third precision point, and you can have V1, V2, V3. So the goal is finding A, angle of alpha. If you know the length of A and the angle of alpha, you can locate O2. We want to find B and the angle of theta 1. What is the length of second link, and what should be the starting position for the first link. And we would like to find C and gamma 1 on the first diagram. So, question on this. Alright, we are on the first diagram, V1, V2, V3. I will connect O to point P, OP, vector OP. The X components, I can write vector OP is summation of V1, V2, and V3. If I add them up, if I add these three vectors, this plus this plus this, I'm going to end up to OP. And what would be the X component of OP? X component of OP would be x1. So x component of OP would be x1, which is the coordinate of point P at the first precision point, would be v1. V1 would be the length of the link, which is a cosine of alpha, plus b cosine of theta 1 plus c cosine of gamma 1. The angle of this vector theta 1 times the length of this link, which is b times cosine of theta 1, the length of this link, which is c cosine of gamma 1. So this is for the x component. For the y component, it's going to be y1. It's a sine of alpha plus b sine of theta 1 plus c sine of gamma 1. So we have 3 precision points. So this equation can be written for theta 2, gamma 2. Theta 2, gamma 2. Alpha is not changing because, as you see, the mechanism, when the mechanism is moving, this vector is fixed because joint O2 is not rotating. It's not moving. So we are going to have 6 equations. A cosine of alpha plus b cosine of theta 2 plus c cosine of gamma 1. A sine of alpha plus b sine of theta 2 plus c sine of gamma 2. And x2, y2. x3 would be a cosine of theta 3, alpha cosine of gamma 3, and y3 is going to be a sine of alpha plus b sine of theta 3 plus c sine of gamma 3. So we get 6 equations. Because we have 3 precision points, I can write for 2 equations per each precision point, totally 6 equations. Then next step, I'm gonna write same as function generation. I'm gonna write each angle with respect to its first precision point. So theta 2 can be written as theta 1 plus theta 1 2. Theta 3 would be theta 1 plus theta 1 3. So then if I rewrite the equation, this 6 equation is going to be a cosine of alpha, b cosine of theta 2 is going to be theta 1 plus theta 1 2, and gamma 2 is going to be gamma 1 plus gamma 1 2, and for 3 is going to be theta 1 plus theta 1 3, and gamma 1 plus gamma 1 3. Here I'm using theta 1 plus theta 1i instead of theta I. For I equals to 1, you are going to get theta 1 equals to theta 1 plus theta 1 1. Theta 1 1 is 0 because theta 1 minus theta 1. So you end up with theta 1. But it's going to be valid for theta I equals to 2 and I equals to 2. I just summarized the equation in this form. And the right hand side will be x1, y1, x2, y2, and x3, y3. Any question on this? To simplify the notation, I defined some intermediate variable. A cosine of alpha, I defined this as a P. B cosine of theta 1, I define this as a Q. P and Q is going to be these two sides. A cosine of alpha and A sine of alpha. And these are B cosine of theta 1, B sine of theta 1 as a S, and this as T, and this as U. So, back to this equation. If I want to rewrite this two equations as a form of P, Q, and R, A cosine of alpha would be P. Then if I expand the equation, I will get something like this, as you see as a term of PR, PQR, S, T, and U. We have done this before, so we get 6 equations. For example, the first equation is going to be it's going to be P plus R plus T equals to X1. Second equation is going to be Q S plus U. This equation, A cosine of alpha is going to be P. B cosine of theta 2, we write theta 2 equals to theta 1 plus theta 1 2. If I expand this, it's going to be B cosine of theta 1 cosine of theta 1 2 minus B sine of theta 1 sine of theta 1. So this term, it's going to be B cosine of theta 1, which is R cosine of theta 2. I didn't define that, so it's going to be there. B sine of theta 1 is S times sine of theta 1. So I can replace this one by this one. I mean, I can replace this by this term. And C cosine of gamma 1, something like this. It's going to be C cosine of gamma 1 cosine of gamma 1 2 minus C sine of gamma 1 sine of gamma 1. So this is T, this is U. So if I replace this, it's going to be R cosine of theta 1 2 minus S sine of theta 1 2 plus T cosine of gamma 1 2 minus U sine of gamma 1. X1 is now, because we are given with the coordinates of point P in all 3 precision points. X2, Y2 are now. P, Q, R, S, T, U are unknown so far. Theta 1 2 is unknown. So I'm just writing P, Q, R, S, T, U, theta 1 2. Gamma 1 2 is known. We know what should be the orientation of coupler from first position point to the second position. So I don't touch this. In this equation, I already covered everything. In last equation, I'm gonna have theta 1 3. So, and I already covered all other unknowns. So the number of unknowns would be 1, 2, 3, 4, 5, 6, 7, 8. Number of equations 1, 2, 3, 4, 5, 6. So 3 choices. We pick theta 1 2 and theta 1 3. As a free choice. What would be the rotation of input link from first precision point to the second and from first to the third? You pick it as a free choice. When you do that, you are going to get 6 equations by 6 unknown. You can solve for P through U. in this system equation. Then, after you find P, Q, R, S, T, and U, P was A cosine of alpha, Q was A sine of alpha. P is known, Q is known, you already calculate, solve for that. Find A and alpha. You find A and this angle by knowing P and Q. By knowing R and S, R is B cosine of theta 1, S is B sine of theta 1. By doing this, you find B and theta 1. B and theta 1. How can I find B? You have done this before. R square plus S square. This square plus this square, you can get rid of theta 1. You get B, and then plug in here, solve for theta 1 here, and solve for theta 1 there, find the magic. So you find A and alpha, you find B and theta 1. By looking at T and U, you will find C and gamma 1. So and X and Y, you know the angle of alpha, you know the A, so you can find the location of O2. You know theta 1, you know B, you can find the location of A. You know gamma 1, you know C, you will find the location of point P. This is vector V1, V2, V3. So we are done with the first half of the mechanism, or first with diad 1. I need to find the location of point B and location of joint O4. So this is the left hand side diad, this is the right hand side diad. So we already synthesized or designed or sized the left hand side diad with the red dashed line. So I'm now looking at these three vectors, V4, V5, V6. It's similar to the first, to the left hand side diad, except there is one tricky part. So if I get rid of this, V4 with the angle of beta and the length of D, then this is the length of E with the angle of P and point P is there with the angle of eta. This is D, this is E, this length is F. V4, V5, and V6. Now, same as left hand side there, connect O to point P. OP would be V4 plus V5 plus V6. V4 X1 V1 V4 would be D cosine of beta plus E cosine of phi. Let me use the I term. Plus F cosine of eta I. And Y I would be D cosine of beta plus E cosine. We have 3 precision points. For each set of I, we get 2 equations. 2 equations, 2 equations, and the last set of equation, we are going to get 6 equations. Again, same as left-hand side diagonal, we write phi I equals to phi 1 plus phi 1I. And eta I will be eta 1 plus eta 1I. We write every equation with respect to first precision. Then the equation is going to change to this. Instead of having phi 1I, phi I, sorry, we are going to have phi 1 plus phi 1I. And eta I should be replaced by eta 1 plus eta 1. I define P prime D cosine of beta, Q prime D sine of beta, R prime as an E cosine of P1, S prime E sine of P1, T prime F cosine of eta 1, and U prime as a F sine of eta 1. Intermediate variables to simplify this. The unknowns on the left hand side were P, Q, R, S, T, U. Here it's going to be P prime, Q prime, S prime, T prime, U prime. We don't know phi 1, 2, phi 1, 3. We don't know that. Also, we don't know eta 1, 2, eta 1, 3. The difference between left-hand side diad and right-hand side diad is here we have 8 unknowns. 10 unknowns compared to 8 unknowns on the right-hand side. But my question is, we can change it to 6. We can change it to the 8 unknowns. 2 of these variables are known right now. Which 2 angles do? The value of 2 angles are known among these 4. What could be those 2 angles? Do we know phi 1, 2, phi 1, 3, or do we know eta 1, 2, eta 1, 3? Two of them are free choices, but the other 2 should be known. If they are not known, we cannot solve 6 equations, 6 unknown.
We find P1 and P1 because we know they are
no, they are. You cannot because you don't know the length. What is the eta 1, 2 and eta 1, 3? Is the rotation of this length from first precision point to the second and from first to the third. So this line is a part of rigid body, that this line also is part of that. So if this line is rotating by the angle of gamma 1, 2 and gamma 1, 3, there should be the same. And gamma 1, 2 and gamma 1, 3 are now, so whatever is the value for these two, you should pick for these two. So then we are gonna have 1, 2, 3, 4, 5. Pick your 6 unknown here, plus these two, P12 and P13, which are the free choices. We can solve for P prime up to U prime. Is that clear? Because we are gonna use this on the past generation as well. We have two more topics left. One of them is past generation. So past generation is similar to the mass motion generation, except we are given with the coordinates of point P, and we're just interested about the coordinates of point P. But the approach will be very similar to this. So when you solve for P prime to U prime, from these two you can find D and angle of beta. When you know D and angle of beta, you can locate O4. By looking at these two, you can find E and angle of Phi1. Draw the Phi1, go by E, you end up to point B. If you connect point B to point P, it should be, the length should be F, and the angle should be eta 1. If they are not the same, some miscalculation. You should check your calculation if this length is not the same as F and eta 1 to found here. So on the right hand side there, the only tricky part was the value of eta 1 to and eta 1 3, which is the same as gamma 1 to and gamma 1 3. After you find D, E, and F with the corresponding angles, you can draw the mechanism. One of the homework problem, I think problem 3, we are given with the motion generation problem, and we were asked to synthesize the mechanism and draw the mechanism at its 3 precision points. So these are the steps that we need to do to draw the mechanism. Any question on this? All right, I'll stop at this slide. Next, after the break, we are gonna go over past generation and one more topic, and we are done.